Hello there, and then welcome to a brand new lesson. Now in this lesson, we are looking at rationalization of Surds. Rationalization of Surds, and we'll look at both the monomial and then the binomial. We will also introduce a concept known as the conjugate of Surds. So without much I say or do, let's quickly go into it. So when we talk of rationalization, what is it at all? We introduced ourselves to rational numbers, and we said that they are those that can be written as fractions. Surds, on the other hand, are irrational numbers, and most at times it is difficult to divide by irrational numbers. So rationalization is a process of converting an irrational denominator into a rational denominator. So you are changing it from a surd towards a whole number or an integer without changing the value of the fraction. Okay, so this is it as you see on your screen, right? After this lesson, we will know how to do all this rationalization. Now, why is it even necessary? Why do we need to rationalize? As I said earlier on, if you are able to rationalize, you are changing the denominator, which is an irrational number, to a rational number, and then you can easily divide with it, you see. So apart from being able to easily divide with it, it is also the standard way we write numbers. You should always let your denominator be what? A rational number and not an irrational number. We'll be looking at two cases. The first case is when the denominator is a monomial. And in our previous lessons, I have discussed what monomials are. So if we take the square root of a, this has just one term, you see. So it's mono, it is just one. Or something like a root b, okay? So for rationalizing monomial, which we'll be considering as our case 1, all you need to do is to multiply the surd by itself. How does that happen? So if I have the square root of a and I want to rationalize it, all I do is to multiply the square root of a by itself. You see, and if you multiply square root of a by itself, there are ways you can write it. It becomes root a all squared, you see. Or you can also say square root of a squared. Either ways, you realize that this 2 here takes out this square root, or this 2 here takes out this square root. You see, it's like writing 2 root 2 times root 2. You end up getting 4. The root 4. And root 4 is what? 2. These were irrational numbers, but when we multiplied it against each other, we got a rational number. And this is where the term conjugate comes into place, right? So the conjugate of any irrational number is another irrational number that multiplies for them to become what? A rational number. That is what the conjugate means in this case. So 1, for monomials, their conjugates are just themselves. For monomials, their conjugates are just themselves. So let's look at how we can apply this concept. Considering this first example here, it says we should divide 7 by the square root of 3. And as I said earlier on, we do not want to divide by surds, you see. So then what are we going to do about it? We have 7 over root 3. So the best thing to do is to make the denominator rational, you see. Now we make the denominator rational by multiplying it by itself. So that I have 7 over root 3. And since we want the denominator to be rational, we are going to multiply the denominator by root 3. We have said that if you multiply a surd by itself or by its conjugate, it becomes a rational. And that is what we are doing here. Now, as we have done that for the denominator, we have to do the same for the numerator so that the value of the fraction does not change. So times root 3. You see? And with this, we know the square root of 3 times the square root of 3 will give us what? 3. Then 7 times root 3 gives us 7 root 3. You see? So with this, we can just say that our answer has become 7 over 3 root 3. And that is we rationalize. So realize that at this point, our denominator is no more an irrational number as was given to us in the question, but then it's a rational number. We are dividing by what? A rational number. You see, so it's very simple and straightforward. Anytime you want to divide by an irrational number, don't let it happen. Change the denominator so it becomes a rational. And how do we do that? You just multiply the rational number, the said, by itself, and you are good to go. Let's pick another example before we go to the binomial forms. So this is what we have here as our second question, our solution. So we have 10 over 2 root 5. Now, 2 root 5 is an irrational number, you see, and in this case, we want to rationalize it. So we have 10 over 2 root 5. So we can multiply both the numerator and then the denominator by the conjugate of root 5. So that is root 5 times root 5. You see? And with that, what are we going to get? The numerator remains 10 root 5. But for the denominator, if we multiply 2 by 1, you know, we have to multiply the coefficients. So if you multiply 2 by 1, we get a 2. Then root 5 times root 5, it no more remains as an irrational number, but then becomes what? 5. So evaluating further, we have our 10 root 5 all over 2 times 5, that gives us a 10. And as you can rightfully see, it simply means the 10s we have here would divide each other or cancel out. So this 10 cancels out this 10, and we are left with what? Root 5 as our final answer, which means 10 over 2 root 5 then gives us what? Root 5. So this is how we rationalize if our denominator is a monomial. So it has almost been 10 minutes. I would end this here. Then in our next lesson, we'll look at how to rationalize if we have the denominator that is having a binomial. I do hope through this lesson you've been able to understand how to rationalize binomial denominators and sets in general. See you in our next lesson. Bye for now.